Every building that we have seen and spent time in is the product of mathematical principles applied to design and construction. Before building any structure, an architect plans and designs the desired structure. For this, he applies geometry, algebra, trigonometry to get it perfect. They also calculate the probability of issues the construction team could run into as they being designed vision to life in 3 dimensions. Since ancient times, architects have used geometrical principles to plan the shapes and spatial forms of buildings. For more than 2000 years, architects have used the formula golden ratio in architecture. They even used Pythagorean theorem to calculate size and shape of structure. Here we see some mathematical wonders of India where maths is extensively used for its architecture.
The Konark Sun Temple dates back to 12,050 AD. King Narasimhadeva I, a warrior king and the monarch of Eastern Ganga dynasty, is credited with the construction of this temple. The temple was dedicated to the sun god. The temple was built over a span of 12 years with the help of 12,000 artisans. The temple was declared a UNESCO World Heritage Site in 1984. The Konark Temple is a fine example of architectural brilliance of a bygone era when our ancestors relied on their understandings of mathematical concepts to create such mathematical wonders without the aid of any modern technology. The mathematical concepts used in the construction of Konark Temple are the golden ratio, geometry, and symmetry. The golden ratio. Almost all Hindu temples have to follow some guidelines. The height of the temple should be double its width, and height of the foundation, including the steps, should be equal to a third of the total height. This translates to what we know as golden ratio. The Konark temple can be largely divided into two parts, the main temple and the assembly hall. The assembly hall still remains today, while the 229 feet high Shikhara is nowhere to be found due to its destruction in 1837. The Jagan Mohan, which is 128 feet high, still stands and is the principal structure in the surviving ruins. The dimensions of the Jagan Mohan are 857 feet by 540 feet. By using these values, the golden ratio of the Konark Sun Temple can be found out to be 1.58, which is very close to the ideal golden ratio 1.618. Therefore, Konark Temple is a stunning example of the use of golden ratio in architecture. Next, the application of geometry. The temple was built in an angular format. In terms of elevation, there is a huge curvilinear tower called Shikhara, inclining inwards and caved. The main characteristics of the Orissa style are primarily two: the dual and the Jagan Mohana, or the assembly hall. The latter has a pyramidal roof. Both structures are squares internally and use a common platform. The temple is situated within a large quadrangular court enclosed by a massive gate in the east. We can also see symmetry in Konark Sun Temple. The chariot wheel sundial has all kinds of symmetry, be it a point or line or mirror symmetry. Not just the chariot wheels, the whole temple is perfectly symmetrical as well. The whole temple is a perfect example of mirror symmetry. So, the Konark Sun Temple is a spectacular example of an ancient astronomical and mathematical wonder.
Taj Mahal is one among the seven wonders of the world. It is famous for its astounding architecture and beauty. Commissioned in 1632 by Mughal Emperor Shah Jahan to house the tomb for his favorite wife Mumtaz Mahal, the principal mausoleum was completed in 1643 and the surrounding buildings and garden were finished about 5 years later. Symmetry in Taj Mahal. Taj Mahal has got an adorable symmetry to look up to. Equal distance of windows and doors from one another, the formation of minarets, proportions of domes to the archways are some examples of its symmetric feature. Even the pools of water reflect and add a sense of symmetry throughout the site. Geometry in Taj Mahal. The walls and tiling patterns of Taj Mahal are all about varieties of geometric patterns. Next to the tomb lies distinctive pattern of pointed stars made of red sandstone and diamond-shaped tiles made of marble. The symmetrical gardens combine squares and elongated hexagons to create octagons. Even the drainage holes, some of the stones have striking hexagonal pattern. Taj Mahal has got trigonometric aspect. The opposite of theta, that is angle CAB, BC stands for the perpendicular of the Taj Mahal with respect to the ground to the final, that is the tip of the dome. The adjacent of theta, that is AB, is the distance from the center of the Taj to any person standing 100 feet away. Theta equals 79.9, which is the degree of elevation. The person looks up to see the top of the structure of the Taj. The secret behind the beauty of architectural wonder Taj Mahal is because of its golden ratio. Taj Mahal displays golden proportion in the width of its grand central arch to its width and also in the height of the windows inside the arch to the height of the main section below the domes. The main building of the Taj Mahal was designed using the golden ratio. That is why it looks so perfect. The rectangles that served as the basic outline of the exterior of the building were all in the golden proportion. To sum up, Taj Mahal serves as a wonder both in architecture and in mathematical aspect as well.